Here's our grammar for the next version of Mo, which is going to have support for pattern matching of syntax objects and construction of new syntax objects through templates. In the match form, that expression there should produce a syntax value at the Mo level. And then we have a pattern here written as an arbitrary shrubbery that we're going to match against. We expect there to be some percent signs in there that will bind variables that can be used in this expression to the right. If it doesn't match, then we will evaluate the else expression. Meanwhile, quote marks as an expression, as opposed to at the beginning of a match, that produces a syntax object. And there may be percent signs inside there, which corresponds to escapes where we should substitute. So that means our expression type in our interpreter now has a match e case and a quote e case. Match has 4 pieces: the expression to produce a syntax object, the match against, the pattern that we match against, the then case when the pattern does match, and the else case when it doesn't. Meanwhile, a quote is going to have just a template inside of it. And we'll represent both templates and patterns using syntax at the Shplait level. But we will not use Splait's pattern matching to work with these syntax objects. The result of a quote e expression is going to be a syntax object value, so we need a new syntax v in our value. Again, we'll represent those syntax objects using Splait's syntax objects. Very much like the way we use int inside of an int v to represent Mo integers using Shplait integers. But to implement matching on those syntax objects, we're not going to use Shplait matching, we're going to implement it ourselves. So we're going to have a group match function that takes a pattern and an argument, each represented as syntax. And it will tell us whether the group matches or not. For example, if we have 1 plus 2 as the pattern and 1 plus 2 as the argument that we're trying to match against, well, clearly that matches up because 1 plus 2 and 1 plus 2 are the same. 1 plus 2 does not match 1 times 2, though. So our group match will need to walk over these syntax objects and discover that plus is not the same as times and report false. If we have a percent sign in our pattern, that means an escape where x can match anything. So here we want to say it does match because x is consistent with 1, and then the plus and the 2 match up okay. But just returning true is not enough information, right? Eventually we want to use x, so we need to know that x actually matches to 1, so Boolean is not really enough of a result here. Let's try returning an environment instead, since that's the convenient way we have to match a name like x to a value like a syntax v1. So a closer approximation of group match is to take this pattern in this argument and say, yes, it matches with x mapped to 1. We can have multiple escapes in our pattern, and so our environment might return multiple matches, in this case for x and y. Keep in mind also that these variables like x don't have to match a single term, they might match multiple terms. So here, x plus y matches as long as we let x be 3 times 4, that is a group of 3 terms, whereas y matches 2 at the end. And remember that matching is greedy. We'll use as much as we can for x, as long as we have enough left over to match the rest of the pattern. Now what happens at this point if we have 1 plus 2 matched against 1 times 2? We're supposed to return an environment, but that doesn't let us say false. Returning an empty environment means success, but no variables inside the environment. So environment's not quite right either. We need to use option of, so we can distinguish between matching and not matching, and also provide an environment when we do match. So 1 plus 2 does not match 1 times 2, so group match will return none in that case. But 1 plus 2 does match 1 plus 2, and in that case we'll return an empty environment with sum. And if we have some variables like x, that's again in a sum. That's the matching side. To implement the template side, where we have a Mo expression that creates a syntax object, we're going to need a substitute form, because this shrubbery here might have percent escapes in it, where we need to substitute in values for variables. So we're going to have a group subst function which takes the syntax object, that is the shrubbery there, and also environment that we use for looking up substitutions. So if we have 1 plus 2, there's nothing to substitute, so group sub should just return it right away, and it doesn't matter what's in the environment. But if we have %x plus %y, then we need an environment that has x and y in it, and we'll take whatever x is and put it in place of x, and whatever y is and put in place of y, so we would get 3 times 4 plus 2 in this case. So those are some functions we need to write: the match function and the substitution function.